All right, welcome back, kiddos. Now we are moving on to our next part in Unit 13. We're going to talk about independent and dependent events, right? You may know of a definition of what independent means and what dependent means if you're an independent person. Think about that, and let's talk about extending that into. So, first thing is independent event. Okay, so what is an independent events are not affected by previous events. Okay, so this is a very important idea. So it's not affected by previous events. So imagine you have a coin right over here, right? And if we flip it, it could come up heads or it could come up tails, right? Each has a 50-50 chance, zero point 0.5 and zero point 0.5. The coin does not know if it came up heads before or if it came up tails. And each toss of the coin is a perfectly isolated event. Okay, so it has nothing to do with the next time that you flip a coin. So, example, you toss a coin and it comes up heads 3 times. What's the chance that the next toss will also be a head? Right? So, say you get a head first, right? Then you get a head, then you get heads. Then you might say, okay, what's the next one going to be? Some people may think, okay, the next one has to be tails because I got heads in a row 3 times in a row, so the next one should be tails. But the chance is simply still 1/2, just like any other toss. What it did in the past will not affect the current toss. Okay, the past will not affect. Okay, that's what an independent event is. Okay, so some people think they're overdue for a tail, right? But that's what's called the uh, gambler's fallacy, because every toss is truly a independent one from the previous tosses. So if you say, "Oh, my tail is due," or "Just one more go, my luck's going to change," that's called the gambler's fallacy. Okay? Your luck may change, but it has nothing to do with the toss of the coin because each one has an equal chance. Okay, so that's an independent event. Okay, so independent events are not affected by previous events. Okay, so that's an independent event. Now let's talk about dependent events. Okay, so dependent events means they can be affected by previous events. Okay, they can be affected. Okay, so imagine, here's our example, drawing 2 cards from a deck. Okay, so a deck of cards is 52 cards. Okay, 52 total cards. Okay, so 2 cards from the deck. After you take the first card from the deck, there's the abilities change as you pull them. So imagine if you said, "What's the chances of you getting a king?" Okay, for the first card, chance of drawing a king is 4 out of 52, right? Because we got a king of hearts, right? Then we have a king of spades. We got a king of diamonds, right? And a king of clubs, right? So we have 4 kings out of 52 cards, right? So our odds are 4 out of 52, just like we practiced last time, right? So we could write that as P of king. Okay, so that means the probability of getting a king. That's how we write that. Probability of getting a king. Okay, but for the second card, if the first card was a king, right, then the second card is less likely to be a king because there's only 3 left, right? If you took one out, then there's only 3 left. Okay, so you would say the odds of getting another one are 3 out of 51. Right? But if the first card was not a king, then the second card is actually different odds. It's more likely to be a king because then you would still have those same 4, but there's only 51 cards, right? So if it is affected by a previous one, then that's what's called dependent. Okay, so this is because we removed cards from the deck. So when we pulled one out, that's what happened. So we have what's called replacement. Okay, so replacement is when we put a card back after we draw it. Okay, and then if we do that, the chances don't change, and then that's independent. Okay, that's like what we practiced last time. So if we put it back, it's independent because it doesn't change. We still have the same amount below. Okay, but if it's without replacement, the chances will change, and that means the events are dependent. Okay, so without replacement, it is dependent. With replacement, it's independent. All right, keeping that in mind, let's get right into some practice. Okay, so how can we tell? You may be asking yourself, how can we tell if it's independent or dependent? Okay, I knew that you might be asking that question. So here's an easy way for us to determine if it is independent or dependent. Okay, so if it's independent, let's write this right up here at the top. So if probability of A, okay, times the probability of B is equal to the probability of A and B happening, then it's independent. Okay, then it's independent. If not, then it's dependent. Okay, so that's what we want to remember. Okay, if the probability of something of one times the probability of the other is equal to the probability of both of them happening, then it's independent. If not, it's dependent. All right, so that's how we're going to tell, and that's what we're going to do between these two problems right over here. We're going to see on these problems if they are independent and or dependent. So we are going to use our Desmos calculator. So just like I've described to you, I've added this calculator, put this website on our Google Classroom, so you can type that in, desmos.com/scientific, or you can just push that link. Okay, so we're going to use that in our practice. All right, so I'm going to show you using this one compared to our yellow calculator, which we did last time. All right, so let's take a look at this problem right over here. It says, a group of students at a high school took a standardized test. The number of students who passed or failed the exam is broken down by gender in the following table. So the gender, of course, is either male or female in this table. So we have males, 56 of them passed, 8 of them failed. Okay, in the females, 63 passed, and in the females, 9 failed. Okay, so we're trying to determine, okay, so here's what our question is, determine whether gender and passing the test are independent. So that's what we're comparing, if gender and passing the test are independent. So that means, does it matter if you're male or female, whether you're going to pass or fail, or are they equally likely? Okay, I'm sorry, are they independent of each other? Do they not make any connection? Okay, so we're going to use our test right here that we talked about, and we're going to round all probabilities to the nearest thousandth. Okay, so thousandth means 3 decimal places. Okay, so we're going to round to the nearest thousandth. That's 3 decimal places. All right, so let's break it down into the steps of what we're going to do. Okay, so right over here. Okay, so the first step that we're going to do is we need to add all the columns. Okay, so remember, columns go up and down, so just as like we practiced last time. So we're going to add all the columns. So if we put that into our calculator, if we put 56 plus 63, that's going to equal 119. Okay, so we put 119 over there. And remember, you can actually draw on your screen with this, just like that on your screen if it's helpful. Okay, next we need to do 8 plus 9. Okay, so 8 plus 9 is equal to 17. Okay, so we have those two totals right over there. Okay, second thing, we need to add all the rows. Okay, and we know rows go this way and this way. Okay, so we're going to say 56 and 8. That total right over there, right? 56 plus 8 equals 64 all day, right? So we're going to say that's 64 right over there. Okay, and I actually like to do this. I like to make these boxes right here to make it even easier. Okay, so next we're going to do 63 plus 9, right? So 63 plus 9, that equals 72. Okay, so let's put those totals over there. 72. Okay, now remember, right over here, we said this has to match this way and this way. Okay, so this total and this total. Okay, so if we put those in our calculator, okay, we are going to get the total of 136. Okay, so this is crucial. This is very important. This is, we're going to use this in all the denominators. Okay, but because this is a total of all students. Okay, so that's a crucial number that we need to get. So we total all the rows, and then we total all the columns. Okay, next, number 3. Okay, so number 3, we need to calculate the probability of the first one. So let's just break it down into male. Okay, so probability of male, right? So we could say the P of male is equal to, okay, so what's the, that's going to be equal to the total male, right? So the probability of being male is the total male over the total students. Okay, so that means that's going to be equal to, so that's the probability of a male is going to be equal to, we said the total males, so the male total, okay, total males is at 64, over, we said the total number of students. This is coming in on all the denominators, right? The total number of students is 136. So hopefully that makes sense. The probability of being a male is 64 people out of 136 total. So that probability is 64 over 136. Okay, and so we'll use that here in just a moment. All right, next, step number 4. Okay, so step number 4, we're going to find the probability of failing. Okay, so that's going to be equal to, probability of failing is equal to the total failures over the total number of students. Right? That's the probability of failing is the total number of failures over the total students. That'll give us the probability of that. So let's calculate that. The probability of failure is equal to the total fail, which you said was 17, right? Over the total number of students, which once again we said was that 136. Okay? All right, next, we're getting there very close. The 5th step, we're going to find out the probability of male times the probability of failure. Okay? We're going to try to do that, and we're going to see if it's equal to the probability of being male and failing, right? Probability of male times the probability of failing. We're going to see if it's equal or not. Okay, so probability of male times the probability of failure. So we said the probability of being male was 64 over 136. So that's going to be 64 over 136 times 17 over 136. Right? 17 over 136. Okay, so let's put that into our calculator. And I'm going to show you with this Desmos calculator right over here. So let's take a look at this. Okay, so let's go ahead and type this into our calculator. So this is a little trickier to type into our yellow calculator, but you can do it. If you did that in your yellow calculator, you'd want to use parentheses around here. Okay, but I'm going to show you in this calculator because I think it might be a lot easier. But either way, whatever's best for you. So we're going to type in 64 over 136. So we're going to type in 64 divided by 136. Okay, then we're going to push the right arrow key to go next to it. I'm going to push times. Okay, and then I'm going to put that 17 divided by 136. Okay? So what I like about this is that it automatically gives me that decimal, and if I wanted to see if that can convert to a fraction, I can easily push that button right over there. Okay, so this is a different type of calculator that you can use maybe on your test as well. Okay, so let's go ahead and approximate that. So we said the nearest thousandth, right? So we said 3 decimal places. So let's see over here. So that's going to be 0.05. Let's write down 4. So 0.0588. So it's going to be approximately 0.0588, right? So let's look at that now, right? We said the thousandth place is right over here, right? So we look next door to ask what to do. Okay, so what do you think? What does that 8 tell us to do with this? It's 5 or more, right? So we raise that score, right? So here's what we need to think about. Okay, this 8 gets raised to a 9. So let's bring down a 9. Okay, then we're going to bring down the 5. Okay, and then we're going to bring down that 0. Okay, so this one is 0.059. Okay, so that's what we did first is we saw what one probability times the other one is. Now we need to compare it to the probability of A and B happening. Okay, so let's take a look at that. Okay, so the probability of A and B is the probability. So number 6, we need to see the probability of male and fail. Okay, so the probability of being a male and failing, if we look right over here, that's going to be from our table. So male and failed is this number right over here, 8. Okay, so that's going to be 8 out of our total of 136. Remember we said all these are going to be the same amount. That's going to be 136, that's going to be 136, that's going to be 136. All the denominators are the same. So let's go ahead and see in our calculator what that is. So what I also like about this Desmos calculator, okay, is that we can just go over here and we can push that enter button, and then it will allow us to look at the other information at the same time. So let's put that in our calculator. 8 divided by 136. Okay, so if we look at that, they're both exactly the same, right? They're both going to round to 0.059, right? 0.059. So that's going to be approximately 0.059. Well, let's compare those. We said this one was approximately 0.059. Okay, this one's approximately 0.059. So they are the same. Okay, so that's what we need to recognize with this. Okay, so since the probability of A times the probability of B was equal to the probability of A and B, then it is independent. Okay, this one is independent. So let's go ahead and fill in our information on here. So we said the probability of male times the probability of failure to the nearest thousandth, right, was 0.059. So we're just going to put that there, 0.059. Okay, and then we said the probability of male and failure was also 0.059, right? So these two results are the same, right? That's the word that they use. So these are independent. Okay, so I know that took a lot of calculations the first time, but we're just going to follow those same steps. Okay, so total everything out, and then you're going to calculate the 1 with keeping our total on the bottom. As we mentioned, there's going to always be that same total, and then we are going to compare those. All right, so let's take a look at another example. Okay, so this one, as you might imagine, is going to be showing you one that is dependent. So let's take a look at how that would look for us. Okay, so let's look at this example for dependent. Now, this all reads the same up here, so we don't really need to focus on that, other than when we look at what it's asking for determine. So it wants to determine whether the gender and passing are independent. Okay, so the same thing, but that's where we look at where our question is. All right, so it says it also still wants it to the nearest thousand. So let's go through our steps. Okay, so the first thing we want is going to total the rows. Okay, so if we do it this way, let's go ahead and make our boxes, right? All these boxes. Okay, so if we total our rows going this way, that 23 plus 58 gives us 81, right? Okay, so if we do this, 142 plus 145 plus 2 is 147. Okay, if we do it this way, 23 plus, so the next thing we want to do is total our columns, right? Okay, so if we do that, we said 23 plus 145 is 168. Okay, 58 plus 2 is 60. Okay, and we remember this should total the same as this, so check our work on that. 168 plus 60 is 228. Okay, so remember this is our main total that we're looking at, that 228 number. Okay, so that's what we're going to be using in the denominator. All right, so let's look at our determination. So there's gender and passing. So let's just see if male and passing, male times passing is equal or different from male and passing. All right, so the first thing we said, number 3. All right, we need to find the probability of being male. Okay, so probability of being male is the total male, right? So we said total male over total students, right? Okay, so that means it's going to be equal to total male. Total male is our 81, right? Our total students that we talked about is going to be this number right over here, 228, right? 228 right there. All right, next. We said our next step is to find out the probability of passing, all right? So probability of passing is equal to the total passing over the total students, right? So the total passing is that 168, right? Over the total, we said always is still going to be that same 228. Okay, so step number 5, we wanted to see the probability of male times the probability of passing, right? Okay, so we said that's going to be that 81 over 228 times 168 over 228. Okay, so if we put that into our calculator, that's going to give us approximately 0.2617, right? But remember, we want it to the nearest thousandth, so let's underline that thousandth. Remember, we said the thousandth is going to be that 1 right there, right? So we're looking to that 7 to ask us what to do with that 1. We're going to raise that 1 to a 2. Then we're going to bring down the 6 and the 2, right? So the answer on that, on number 5 for the multiplying is 0.262. So on number 6, we're going to find the probability of male and passing both, right? So that's going to be, let's look at our table right over here. So male and passing, that's right there, right? That's that intersection. So that's at 23. That's what we're going to use. All right, so 23 over that full total, that 228, right? 228. We said it's always going to be that same thing. So if we put that into our calculator, that's going to give us approximately that 0.1008, right? And once again, we said we wanted to go to the nearest thousandth. So we look at that 8 to tell us what to do with that 0. We're going to raise that to a 1, right? Then bring down that 0, then the 1, then that. So that's the answer on 6. So what did we find? Well, we know that they are not equal, right? They are not equal. Okay, so what's our final determination then? If they're not equal, then they have to be dependent. So dependent because the probability of A times the probability of B was not equal to the probability of A and B. Okay, so let's go ahead and type in our information over here. It said the probability of male times passing was 0.262. Okay, and the probability of male and passing was at 0.101. So the two are different, so they are dependent. All right, folks. So I know that can be quite tricky with those calculations, but just follow those steps and we'll be fine. So we're going to add all the columns, add all the rows. We're going to calculate the totals over totals for probability total over total. Then we're going to find the intersection on our table. That's where we're going to compare the intersection, which is and versus multiply. So if you have any questions, let me know. You got this.